Welcome back to the deep dive. Today we're jumping straight into the Middle Jurassic.
That's right. We're talking about Agilisaurus louderbacki. It lived around, what, 168 to 161 million years ago?
Exactly.
Hmm.
And we've got scientific papers, museum info, basically the good stuff.
Hmm.
Our mission today is really to dig into what makes this dinosaur, this agile lizard, so interesting. We're focusing particularly on its teeth, which are quite something, and where it sits on the family tree.
Yeah, Agilosaurus might not be, a T-Rex or a Stegosaurus in terms of fame,
Right.
but it's actually super important for understanding how ornithopods evolved, the group that eventually led to the big plant eaters like hadrosaurs.
Okay, let's start with that name then, Agilisaurus. It
Yeah.
kind of gives the game away, doesn't it?
It really does. You've got Agilus, which is Latin for agile, obviously,
Uh-huh.
and Sauros, Greek for lizard. So yeah, right away, the scientists who named it figured it was probably lightweight, quick. Those long legs were a clue.
Nimble. And the second part, Louderbacky. That sounds like it's named after someone.
It is indeed. It honors Dr. George Louderback. He was an American geologist, and way back in 1915, he was the first to actually recognize dinosaur fossils in Sichuan province, China.
Wow, 1915. So long before this specific dinosaur was found.
Exactly. So the name kind of ties together the dinosaur's agility and a key figure in finding fossils in that whole region. Pretty neat.
That's a great connection. And it leads us right into the discovery itself, which has this really unique link to a museum, you said.
Oh, absolutely. The holotype specimen, that's, the main example that defines the species.
The reference point.
Right, the gold standard. It was found in 1984. And the amazing part, they found it while they were building the Zegon Dinosaur Museum.
No way. Literally building the museum on top of potential discoveries.
Pretty much. It's almost poetic, isn't it? The museum sort of rising right out of the ground that held these fossils, and that holotype is still housed there.
And the Zhejiang area, that's a big deal for Jurassic fossils, correct?
Oh, huge. It's right near the Deshantu Quarry. I mean, that place is famous.
What else came from there?
All sorts. Big stuff like the sauropod Shinosaurus, the theropod Schwanhanosaurus, the early Stegosaur, Huayangosaurus. It's a real hotspot.
So Agilisaurus was found right in the thick of it.
Exactly, within the lower Shaximiao Formation. And that dates it to the middle Jurassic Bathonian through Colovian stages, roughly. So like we said, 168 to 161 million years ago.
Okay, so picture this. Agilisaurus living alongside these much larger neighbors. What did our little agile lizard actually look like? You mentioned the holotype was pretty complete.
Remarkably complete, yeah, just missing a few bits from the left legs, but you can basically mirror image the right side to figure those out.
So we have a good idea of its size.
We do. It wasn't huge, maybe 3.5 to 4 feet long, something like that, about 1.2 to 1.7 meters.
And height?
Maybe stood about 2 feet tall at the hip, so 0.6 meters. Weight-wise, probably around 40 kilos, maybe 90 pounds, so definitely living up to the Agile name with that lightweight build.
And that agility, it wasn't just a guess from the skeleton. The legs tell the story, too.
Oh, yeah. Its lower leg bone, the tibia, it's actually longer than its upper leg bone, the femur.
Ah, the runner's ratio.
Exactly. In animals that run on 2 legs, that usually means they're built for speed. So Agilosaurus was likely a very fast little runner.
Using his tail for balance, presumably.
Yes, a long tail for counterbalance. Though, interestingly, there's some thought it might have dropped down to all 4 sometimes, maybe when it was foraging for food close to the ground.
Makes sense. And what was it eating? You mentioned leaf-shaped teeth earlier.
Right, those teeth are a dead giveaway. They're shaped perfectly for shearing and grinding up plants. Definitely an herbivore, adapted for a pretty abrasive, tough plant diet, it seems.
Okay, but you also teased a dental surprise.
Yeah.
What was so unexpected about these teeth?
Yes. This is where it gets really cool. If you look closely at the enamel on its teeth, it has this wavy microstructure.
Wavy enamel, okay.
Well, the surprising thing is scientists used to think that kind of enamel was, like, exclusive to the hadrosaurs, the duck-billed dinosaurs from the Cretaceous.
The much later dinosaurs.
Tens of millions of years later. And it's also turned up in another ornithopod, Chungshinsaurus. Finding it in Agilisaurus completely shakes up the timeline for when this adaptation evolved.
So it pushes the origin way back.
Way back. It suggests that this way of making teeth tougher to handle abrasive plants, well, it had a much earlier and maybe more complex start than we thought. Agilisaurus was unexpectedly sophisticated for its time, dentally speaking.
So a Middle Jurassic dinosaur was already rocking tooth tech we thought belonged to the late Cretaceous.
Basically, yeah. It really makes you rethink how these dental features evolved in the whole ornithopod group.
Fascinating. Now, there was also a hint, something about burrowing. That seems counterintuitive for a fast runner,
It does sound a bit odd, right? But here's the thing. Unlike a lot of other two-legged runners, Agilosaurus didn't have those bony struts that make the tail really stiff.
which they use for balance when running fast.
Exactly. So the thinking is maybe Agilosaurus had a more flexible tail, and why would it need that? Well, one hypothesis is that it could have been useful for maneuvering inside burrows.
Huh. So maybe it wasn't always running away. Maybe sometimes it hid.
Possibly. It's still just a hypothesis, you understand. But it paints a different picture, doesn't it? A fast runner that could also potentially disappear underground.
It definitely adds another layer. How would that work, though? Burrowing for escape or shelter?
Could be both, really. A burrow offers protection from predators, sure, but also from harsh weather, maybe a safe place to rest. So you've got speed and potentially a safe hideout. For a small herbivore in a world with big predators, that sounds like a pretty good combination.
Okay, interesting. And when it wasn't burrowing, was it out and about during the day or more active at night?
Good question. We can get clues from the scleral rings. Those are the bony rings inside the eye socket.
Right. They relate to pupil size and light gathering,
Exactly. By comparing Agilosaurus's rings to modern birds and reptiles, the evidence suggests it was probably diurnal, active during the day.
which is different from some other herbivores.
Yeah, some of the really big ones are thought to have been cathemeral active in short bursts throughout the day and night. So Agilosaurus being diurnal might mean it had a different ecological niche, different interactions with its environment and the other animals around it.
So let's recap. Small, fast, plant eater, surprisingly advanced teeth for its time, maybe a burrower, active during the day.
Yeah.
Now let's talk classification. Where does it fit in the grand scheme? Sounds like that's been tricky.
Oh, it has. Very tricky. I mean, initially they put it in a group called Fabrisauridae.
I vaguely remember that name.
Yeah, but that family isn't really considered valid anymore by most paleontologists. These early ornithischians the group Agilisaurus belongs to, they've been tough to sort out.
So where does the thinking place it now?
Well, several recent studies looking really closely at its anatomy place Agilisaurus as the most basal member of Euornithopoda.
Okay, basal and Euornithopoda. Break those down.
Right. Basal just means it's near the base or the root of that particular branch on the evolutionary tree. It branched off earlier than the others in the group.
Got it. Like an early version.
Sort of. And Euornithopoda, that's the big group that includes basically all the ornithopods that are more closely related to the later hadrosaurs than they are to another group, the Heterodontosauridae.
Ah, the heterodontosaurs. Those are the ones with the weird fang-like teeth up front, right?
Mhm.
And their position is debated too.
Exactly. That's another puzzle. Where Heterodontosauridae fits is still argued over. Some scientists think they might actually be closer to the marginocephalians, the group with ceratopsians like Triceratops and the dome-headed pachycephalosaurs.
So the whole base of the ornithischian tree is a bit messy.
It is. It shows how science works, new fossils, new analysis methods. Our understanding keeps changing. So placing Agilosaurus as basal within Euornithopoda is significant because it means it probably shows us some of the original ancestral features of that whole major lineage.
But there are other ideas about where Agilisaurus fits too.
Oh, yeah. Because it has this mix of features, some studies have placed it even more, basically like maybe basal to both orthopods and marginocephalians.
Wow. So it could be close to the split between those huge groups.
It's a possibility. It really highlights how important this little dinosaur is for figuring out those major branching points way back in ornithischian evolution. What scientists are actually looking at are tiny details, the shapes of specific bones in the skull, the limbs, the vertebrae, comparing them across all these different early dinosaurs.
Trying to find the pattern that best fits the evidence.
Precisely. Think of the family tree like a big river system. Agilisaurus is sitting right near where one of the main channels, Euornithopoda, starts. It tells us something about what that channel looked like right at its source.
Okay, that makes sense. Now, wasn't there another species initially put into Agilisaurus? Something multi-dens?
Ah, yes, the Agilisaurus multidens story. Good catch. So originally that species was called Yandusaurus multidens.
A different genus.
Right, but then based on some similarities someone saw with Agilisaurus louderbacki, it got moved. Temporarily, it became Agilisaurus multidens.
But not everyone bought it.
No, the classification didn't really stick. Other paleontologists looked at it and weren't convinced it belonged in Agilisaurus. So eventually in 2005, it got reevaluated again, and it got its own brand new genus, Exenlusaurus. So now we have Agilisaurus louderbacki and Hexanlusaurus multidens. Related, but distinct.
Okay, so Hexanlusaurus is its own thing.
Yeah.
How does it relate to Agilisaurus in terms of evolution?
Most studies suggest Hexanlusaurus is probably a little bit more derived.
Meaning slightly further up the branch, less basal.
Exactly. It seems to have appeared a bit later in evolutionary time, and it shows some features that are considered slightly more advanced compared to the very basal Agilisaurus.
Okay, so wrapping this all up, Agilosaurus louderbacki, it's giving us some really fascinating glimpses into the Middle Jurassic, wouldn't you say?
Definitely. I mean, from those surprisingly advanced teeth
The wavy enamel.
to its position, even if it's still debated, right at the base of a major dinosaur group. It's a really key piece for understanding early ornithopods.
And you just can't beat the discovery story turning up while they're building the museum.
It's fantastic. And it really shows how these, maybe lesser known dinosaurs can hold incredibly important clues about the big picture of evolution. That wavy enamel discovery forced a major rethink, right?
Right.
And its basal position, wherever it finally settles, tells us so much about the starting point for these huge successful dinosaur groups.
It really makes you think. We've looked at Agilosaurus, seen these unexpected features, the shifting ideas about its relationships. It kind of begs the question, doesn't it? What other settled facts about early dinosaurs might actually be hiding similar surprises?
That's the exciting part of paleontology, isn't it? There's always more to find, more to reevaluate.
And just thinking about this creature, agile, diurnal, maybe burrowing, with those advanced teeth, what could its lifestyle really tell us about the whole ecosystem back then, its interactions, how it survived alongside the giants? Lots to ponder.
Absolutely. Agilisaurus is a perfect reminder that the deeper we dig, often quite literally, the more complex and surprising the history of life becomes.